Hello everyone, so in this video let us talk about a problem from LeetCode. The problem name is you have to implement a stack using a queue. Now what you can understand is, like, first of all understand what is a stack, what's a queue. So these are different data structures. A stack is that first in and last out, and queues are first in first out type of data structures. So you just have to implement a stack using queues. Now how you'll do that, you will have to write down implementation and solve it using queues, but you have to also write down the implementation of these four operations on which actually stack works upon. So you have to push it inside the stack, you have to pop it from the top of the stack, you have to return the top element as well as you just have to check whether the stack is empty. So let's try to visualize and see how a stack works, and then we'll try to mimic it using a queue. That's the overall observation you can do. And there will be some trades off, obviously, because you're not actually using a stack but you're using a queue instead. So there will be some trade-off of time complexities. We'll talk about that as well. So what actually stack looks like, that this is like a stack. You will keep on pushing elements inside this and they will go on top of each other. So let's say you will first insert 1, then you will insert like 3, let's say insert 2, 5. So they go on top of each other. You will just try to put it on top of each other, and then that's how a stack stores these elements. And if you want to pop it out, you will have to pop it from the top. Okay, so first 5 will pop out, then 2 will pop out, and so on. And then if you want to just check what is the top element, so it's a 5, and if you just pop out this element, then the top element will be 2, and so on. So that's the overall stack. Now if you want to, let's say, mimic a stack using a queue, the queue is like this data structure in which you'll push elements from the back and they will keep on aggregating like this. So let's say you first push 1, then 2 and 3 and so on, and you just have a queue. Now let's say that you have a queue data structure like this. Now if you put, let's say, push some element, the element goes like this, that is 1, then you again push 2, again push 3 and so on. Now in queue, what actually happens is that when you push element, it goes in the very back. Similarly, if you just push an element from the back, it's actually in the very back. You just have to bring it to the very first, because see, in queue, whenever you push element, it becomes actually on the top, not on the back. It's not on the back, it comes on the top. So what my main goal is that whenever I push element, it should not go in the back, but it should go in the very first, again right in the front. So what you will actually do is that you will try to pop every element and bring it to the very back, so that it is like pushing every element from the very start, and doing a circular motion type of thing, and just pushing the last element to the front, so that you are now becoming it and making it like some sort of a queue. No, sorry, like that. So I'll just give you an example. Let's say, let's just remove this out. Let's say that you'll first insert 1, so there is only 1. If you now insert 2, and just also keep track of how a stack works. So let's say you insert 1, and you want to insert 2, so 2 will go on top of on top of 1, but in this queue it will go in back, but you actually want it in the front. Why? Because in queues you can only pop out elements. You want to check out the top element, you can only do it from the very top, like the very first element. If you want to pop out elements, you can only pop out with the very first element. If you want to check what's the top element, you can only check this element. If you want to check if it is empty or not, you can just check the whole size. But so 2 operations can be done on this element. So if you want to make this element, what you actually do is just do a for loop every time you insert an element, and bring every element in front of this element on the back. Okay, because you want this element on the very first chance, like very first iteration. So what you'll do, that whatever elements are in front of this, you just do a for loop over them and just bring them back of this queue. Just pop out from the very first and push it from the back. So let's say that now you have the elements like this, 2, 1, similarly in this manner only. Now if you want to again push 3 inside the queue, like in the stack, let's say, so you have a queue like this. Now you will put it in the back, but what you'll do, you will push this on the very back, and you'll try to push this on the very back, so it will become like this. So 3, 2, similarly like the stack. So you can just assume that this is now what you can say, a tilted, not tilted, but like a resting stack. So this is like a stack only. You can just see that if you just twist this in this manner, then this is like a stack only. But what we are trying to do is that whenever I push the element in the back of the queue, we just like rotate all the elements so that this will come in the very first of the queue, that it will be start acting as a stack. And then whenever you want to do an operation of checking whatever element is on the top, you can just check whatever element is on the front of the queue. Similarly, if you want to just check that what element is there, if you want to pop it out also, you can just pop it out with the very first element from the queue. So it will now implement as a stack. The overall trade-off that we're doing is that in stack, if you want to just push out element, this operation is O of 1, pushing out, popping out top element. But in this, the checking out the top element or popping out the top element is O of 1 only, because you're just checking out from the top of the queue as well. That is O of 1. But now whenever you are inserting an element, you have to move all the elements on the front of the element you are and just push it on the back. So you're doing a continuous circular operation for just pushing one element. So if there are n elements in the queue at any given moment of time, you have to move all the elements, n elements on the back of this particular element to insert a new element inside the queue. So now the pushing operation becomes O of n instead of O of 1 in the stack answer. So this is the trade-off you'll have to do if you want to just like implement a stack using it. So that's the overall logic, else other thing is same. So what we have done is that we have taken a queue, and in the push operation, we just push the element in the back of the queue and then do a for loop over the size of the queue and try to like take out every element from the front and push it in the back of the queue and just pop it out, and just doing a circular operation over all the elements in the front of the queue. That is how you push. If you want to pop it out, you just take out the top element of the queue. That is just doing the same thing as popping out. And if you want to just check what element is on the top, just check the front element of the queue. And if you just want to check that whether the queue is empty or not, you just check it using this function. So that's the overall logic and the code part for this problem. That is how you can implement a stack using. If you still have doubts, you can mention down in the comment box. Thank you for watching this video till the end. I will see you in the next one. Keep coding and bye.